Today we're going to be looking at really section 8.4 in the book, which we're going to focus on shadow problems. So we're going to use proportions to solve real life situations. So let's take a look at this example. It says a 12-foot flagpole casts a 20-foot shadow. A nearby person casts a 10-foot shadow. Find the height of the person. Okay, so essentially how these shadow problems are going to work is we're going to set up a proportion where you just want to be consistent. So when you are setting up your ratios, just like what we were doing when we had similar figures, I had every single numerator be represented as one of the triangles and every denominator be the other. So that's one way you can think about it. The other way you can think about it in this case, especially since we're talking about height and shadow essentially, is we could think of it as, okay, I'm going to take one of the figures and do height over shadow, and then I'm going to set that equal to the other figure, height over shadow. So a couple different ways that you can go about it. So in this case, I think that's what I'm going to do. I am going to look at the height of the flagpole, put that over the shadow of the flagpole. And that will be one of my ratios. And I'm going to set that then equal to the height of the person over the shadow of the person. That's usually how I like to go about setting up my ratios in these word problems. So a 12-foot flagpole, that's the height of the flagpole, casts a 20-foot shadow. So that is the length of the shadow of that flagpole. That's going to equal then a person who casts a 10-foot shadow. So 10 goes on the bottom. I do not know what the height is. That's what I'm going to find. So I'm going to call that X. So then I'm going to cross multiply, or if you want, we could simplify down the 12 and the 20. 12 and 20 are going to be reduced both down by 4. So that would be 3 over 5 to equal X over 10. And then I can cross multiply. So I would have X times 5 to equal 3 times 10, which is 30. So then I can divide both sides by 5, and it looks like the height of the person is going to be, and I'm going to put the units with it, we're talking 6 feet here. So there is my answer. But it was just a matter of being consistent. So if I wanted to do like height over the flagpole over the height of the person, I could do height over height, but then I would have to do my other ratio. I'd have to start with the flagpole on the top, so shadow of the flagpole over shadow of the person. So however you want to set it up, you just want to make sure that you're staying consistent. Let's take a look at another example. A 30-story building casts a 42-foot shadow. So I'm going to say, okay, 30 is the height of that because it's 30 stories, and 42 feet is representing the height or the shadow of that building. So then a 20-story building also casts a shadow, but I don't know what the shadow is. So I'm going to call it X. So we want to find the length of that shadow. So once again, staying consistent, I'm going to do the 30-story building over the shadow of that building. So height over shadow is then going to equal height over shadow. If we want, we could simplify down 30 and 42. So 30 over 42 is going to simplify down because they're both divisible by 6. It's going to simplify down to 5/7. And then I can cross multiply. So we'll have 5 times X to equal 7 times 20, which is 140. And then I'm going to divide both sides by 5. And X is what we're looking for, which is the length of the shadow. Shadow is in terms of feet. So it looks like we're going to have a 28-foot shadow. And there's my answer. Okay, so the first two examples, I gave you a picture. For the most part, you aren't going to have a picture, so you're going to have to sketch one yourself. Okay, but in general, it's always going to be, I'm starting with two essentially right triangles. So there's one right triangle, here's another right triangle, and then I can label whatever it is that is going to represent it, and then I can set up a proportion. So a lighthouse casts a 17-foot shadow. So shadow is going to be on the ground, so I'm going to put 17 on the ground over here. It did not say what the height of that lighthouse is. So I'm going to call that X. It says another lighthouse, which is 14 feet tall, so height, casts a 28-foot shadow. So that's going on the bottom. So find the height of the first lighthouse. So once I have my figure, I know exactly, okay, what's height, what's shadow, and for what figure. So I'm going to stay consistent. I'm going to do height over shadow for the first lighthouse. That's going to equal height over shadow for the second lighthouse. Now, if you want, you can simplify down 14 and 28. They are going to have that reduced down to a half. And now I can cross multiply. So we'll have 2 times x to equal then 17. I'll divide both sides by 2. Looks like we've got a pretty short lighthouse because it's only 8.5 feet tall. But there's my answer. Okay, here's the next one. A 55-foot tower casts a shadow on the ground. So I'm going to sketch a picture of a right triangle. I know the 55-foot tower is representing the height of that tower. It says it casts a shadow on the ground. They haven't told us what that is. If a 10-foot tree, so draw another right triangle, and 10-foot tree is the height, casts a shadow 15 feet long, which is going to be on the bottom. How long is the shadow? And it's talking about the shadow for the tower. So then now that I have my sketch, I know how I can stay consistent with my proportion. So I'm going to do height over shadow for the tower, and that's going to equal then the height over the shadow for the tree. If you want, we can simplify down the 10 and the 15. They're both divisible by 5, which would reduce that down to 2/3. If I cross multiply, we'll have 2x to equal 55 times 3, which is 165. And then I'll divide both sides by 2, and that is going to give me the shadow to be 82.5 feet. And there's my answer. All right, here's the next one. A radio tower casts a shadow 22 feet long. So I'm going to draw my right triangle where if we're given the shadow, that has to be on the ground. At the same time, a 6-foot person, so that's the height, casts an 11-foot shadow, so that's on the ground. Find the height of the radio tower. So now that I have my picture, I can do height over shadow for the radio tower, and that's going to equal height over shadow for the person. So there's nothing that I can simplify here. I'm going to just start cross multiplying. 11 times x is going to equal 22 times 6, which is 132. And then I'll divide both sides by 11, and it looks like then the height of the radio tower is going to be 12 feet. All right, here's our next one. It says Henry, who is 6 feet tall, casts a 4-foot shadow. Oh, sorry, stands 4 feet away from a stoplight, 18 feet tall. Okay, so Henry, who is 6 feet tall, stands 4 feet away from a stoplight, 18 feet tall. Find the length of Henry's shadow. Okay, so notice that the figure that I have drawn here is a little bit different than all the other figures because this time they are telling us the distance that 2 of these things are away. So Henry is going to be dealing with the smaller triangle because the person is going to be smaller than the stoplight. So notice that Henry is 6 feet tall, so that's going to be that little triangle, the height inside. He stands 4 feet away, so that means that this distance right here is the 4 feet because this is where Henry is. Oops, I can spell Henry. And this is the stoplight. And I know that the stoplight is 18 feet tall. It says find the length of Henry's shadow. So this distance right here is my unknown. Okay, so once again, we do want to stay consistent. I do want you to understand that I am still dealing with two right triangles. So one of the triangles is dealing with Henry. So it's Henry's height, which is 6, over his shadow, which is my unknown. That's going to equal then, now I want to do the height of the stoplight, which is 18, over the shadow of the stoplight. But notice that the shadow isn't 4 and the shadow is an X, but it's those two things together. I need to add those two pieces, and together that's going to get me the length of his shadow. So now I'm going to recognize that because I have this binomial, I'm going to put it in parentheses and I'm going to cross multiply. 6 is going to get multiplied by both the 4 and that X, and that's going to equal X times 18, which is 18X. I'm going to distribute the 6, so I have 24 plus 6X to equal 18X. Because I've got X's on both sides, I'm going to subtract the 6X so I can combine those like terms. That gives me 24 to then equal 12X. And then I'll divide both sides by 2, and I'm going to get by 12 to get X to be 2. And we are dealing with feet for the length. Because it's asking for the length of Henry's shadow, and X is representing that shadow. Once we found X, we had our answer. So 2 feet would be that. Okay, so it did take us setting up a little bit more of an increment here because we're talking about the distance that things were away. In the past, the radio tower and the person, they didn't tell me the distance between them, but here they are. So that's why we have one triangle inside of the other. Here's our last example. Becca, who's 5 feet tall, stands 12 feet away from a wall that is 25 feet tall. Okay, so because they're telling us the distance between these two objects, I once again want to sketch a picture where I have one triangle inside of the other. Okay, but I am dealing with right triangles. Becca's going to be the smaller triangle. She's 5 feet tall, and she's standing 12 feet away from a wall, which is 25 feet tall. We want to find the length of the wall's shadow. So what I'm going to do, though, is I'm still going to represent X as Becca's shadow. Okay, so I'm still going to do the same idea as we did in the last example. And I'm going to set up a proportion where if I focus on the triangle that represents Becca, we would have 5 for the height over X for her shadow. And then if I'm looking at the really big triangle, we would have the height of the wall, which is 25, over the length of its shadow, which would be me putting the 12 and the X together by adding them. So now I'm going to cross multiply. We'll have 5 times this 12 plus X to equal 25X. If I distribute the 5, that's going to give me 60 plus 5X to equal 25X. Going to combine my x's by subtracting the 5x. So 60 equals 20x. And if I divide by 20, I get x to be 3. But remember, x is representing Becca's length of the shadow. I want the length of the wall shadow. So that means I need to add 12 and 3 together. That would give me then a 15-foot shadow. So just read everything very carefully to know which shadow we're finding and to know, okay, X is representing which portion of my problem. And that's us using proportions to solve real